Well, greetings, everybody. Somebody sent me this question today from my math lab, and after thinking about it, I thought it'd be good to make a video and go through some of the steps in detail. And I'd already posted a video with somewhat similar problems, but I guess this one does look a little bit different than some of the examples I've already covered in the videos I've made. So let's go ahead and look through this step by step, and I'll have some comments about some of the steps that might open up further conversations between us, okay, if you need more help. So this is from my math lab as you're looking at it here, and we'll put our answer in whatever it happens to be, but let's go work it out over here on the whiteboard, okay? So I've copied down my equation that I was given, and I'll go through some of the steps and tell you about some notes that I've made that are in addition and beyond some of the steps that you actually see over here. So I think that when we solve these equations that have two radicals in them or two roots, like so there's one here, it says root x, there's another here, it says root x minus 24. I think it's easier if you're solving it on paper, right, to isolate one of the roots, okay? So what that means is like get either one of these on one side of the equation by itself. All right, I don't really think it matters which one. So I'm going to leave this one over here on the left-hand side, and I move the root x minus 24 over to the right-hand side. How did I do that? Well, if this is added and I want to move it over to the other side, I subtract it from both sides. And so it says 4 minus root x minus 24. So that's me isolating one of the roots. You don't have to do it that way, but I think it's the, of all ways that you can do it on paper, working it by yourself, I think that that's the easiest way. Okay, now once we do that, we square both sides of the equation, okay? And you might say, why don't you just square one side and leave the other side alone? Well, when we solve equations, we have to keep them balanced. We have to do the same thing to each side. So in this previous step, I subtracted root x minus 24 from both sides, okay? So I'll square both sides. Now, on the left, if I take root x and square it, not much happens because in this case, that square directly cancels the square root. And so all you're left with whatever's inside that root, which is just x. Over here, to square the entire thing that's on that side, 4 minus root x minus 24, then we have to think about it like this, because this is more complicated. We have to think, well, what does it mean to square something? Okay, what it means to square something is to multiply it by itself. So you might say, well, if you had 4 squared, that's 16. But how do you know that? Well, because to square 4 means to multiply 4 by itself. And then 4 times 4 is 16. So that's why the answer is 16. So it's like that. So I got to take, okay, 4 minus root x minus 24 times itself, which is 4 minus root x minus 24. Okay? And then how do I do that? There is a technique for multiplying this sort of thing, and it's called FOIL multiplication. Okay? And that means first, outside, inside, last. So here's what I do. I don't want to mark this up too much, but I'm going to mark it up a little bit for you to see what I mean. The F in FOIL multiplication says multiply the first things in each set of parentheses. So that'd be 4 times 4. That's 16. Okay, so that's F. All right. Okay, so then I've got to go through that in order, like FOIL. So what's the O mean? The O means outside. Okay, so the outside with respect to what I'm multiplying together here would be this 4 times this negative root x minus 24. What's that? What's 4 times negative root x minus 24? Negative 4 times root x minus 24, just like you see there. So there's the outside. Okay. All right. And we keep going. What's next? Inside. So what do we mean there? We mean multiply these two things. Okay. So now I'm taking negative root x minus 24 times 4. What's that? Well, that's actually the same thing. You got a 4 times a negative root x minus 24, so you get this again. You get negative 4 times root x minus 24. So that's inside, okay. And then with L in FOIL multiplication, last, that would be this times this, okay? Negative root x minus 24 times negative root x minus 24. So about that, first of all, a negative times a negative is a positive. See that plus right there? That's why that's plus. But what's root x minus 24 times root x minus 24? Well, anytime you take a square root, and it doesn't matter what's on the inside, but let's say you take a square root with an appropriate number in there, and you square it, you're just going to get that number that's on the inside. I kind of wish I didn't put a question mark. Let's put like a number sign, okay? So if I got any square root and I square it, the square and the root, they just cancel, and you get whatever's on the inside. So that's what's happening here. If I take root x minus 24 times itself, but that's squaring a square root. You're multiplying it by itself. So you just get what's on the inside, which is x minus 24, okay? So that is the FOIL multiplication. Now, with what I got here, I'll look at anything that can be combined or simplified, okay? So what I notice is just looking at all the terms and seeing which ones can be combined or canceled or whatever the case may be, I see this x, and that is unlike every other term that's there. It can't be combined or canceled with anything else. So I've got this x. Next, I might look at it as, well, I've got a 16 and a subtract 24. I've got 16 and minus 24. Those can be combined. What is 16 minus 24? It's negative 8. And then these two middle terms are like terms. Okay? They're like terms because the variable part is the same. Okay? It's like adding apples and apples, as they say. I have 4 root x minus 24 and 4 more of the same thing, root x minus 24. These are the same things that we could consider we're adding together. Now beyond that, I got negative 4 and negative 4. So that makes negative 8 root x minus 24. If these parts were any different, if this was root x minus 25 and that was root x minus 24, they wouldn't be compatible to be combined. Like terms have exactly the same variable part, meaning the part with the x is exactly the same. Okay, so that's what I can get when I go through the FOIL multiplication, combine all the terms that can be combined, and I'll take that, my end result of doing all that, and then that's what goes over here, right there in that step. Okay, now I still have one more root left there. Part of the rationale behind squaring both sides of an equation like this is that we can't really solve this type of an equation with the roots in the equation. Okay, I'm not saying it's impossible to solve it if the roots are there, but for most of us, most of the time, we'll only solve this if we get rid of the roots. Me squaring both sides here allowed me to get rid of one of them. I still have this other one though. So what I'll do is I'll rearrange and I'll try to isolate that root and then square both sides again, because then it will disappear. Okay, so let's try that. Suppose I subtract x from both sides. I do like minus x, minus x. Then I'll get 0 over there. Those cancel. And I'll be left with negative 8 minus 8 root x minus 24. Okay? Now, I want to isolate this root so that eventually, once I get it all by itself, I can square both sides and I can eliminate it. And I won't have any more roots, and I'll be able to solve what's left of the equation. So I will add 8 to both sides. So here you can see I'm adding 8, and I'll get 8 equals, okay, those cancel, negative 8 root x minus 24. And then I am trying to get this root all by itself so that I can apply a square to it and get rid of it. So now what's this 8 doing there? Like here I added 8 to both sides in order to cancel that one and just get it out of the way because I wanted to isolate this root. But what about this? Should I add 8? You see that right there? If I add 8 to both sides, will that cancel this one and get that one out of the way? So what's it doing there? What's the connection between this negative 8 and the root x minus 24? It's multiplication, you know. Here the connection between this term and the other term next to it was subtraction, so I can cancel with addition. But here the connection between this term and what's next to it is multiplication, so I would divide both sides by negative 8. Okay? Because division is the opposite of multiplication. So divide both sides by negative 8. Those cancel because negative 8 divided by negative 8 is 1, which means it cancels. And over here I get 8 divided by negative 8, which is negative 1. Okay, so now I'm here and I've got that root isolated. I would like to completely get rid of it. And I do that by squaring both sides again. I get negative 1 squared is 1. And root x minus 24 squared. Well, the square and the root cancel. I get x minus 24. I can solve this by adding 24 to both sides. I'll get 25 equals x, or if you'd rather say it this way, x equals 25. So it appears that we get an answer right there. You know, I go through all the steps, and I could double check my work. I didn't make any mistakes. I didn't make any miscalculations. And it seems that we get an answer. But the thing about these equations with radicals, and whenever you use this tactic of squaring both sides to get rid of the roots, to get rid of the radicals, is you have to check. It might be that even though you got that answer without making any mistakes, that it might not actually work. That's just the nature of this kind of problem, okay? So the checking part is not an option. Just because you got that fair and square, no mistakes, doesn't mean it actually works, okay? You could say it's a flaw or a defect in this type of problem in the solution that goes along with it. So I put that we must check it, and I asked the question, is x equals 25 a solution to what? Well, the equation we're trying to solve is the one that we started with. We're not trying to solve any of the ones that came up along the way. We're trying to solve the one that we were given in the question, right? So like this one right here, we're trying to find the answer to that. So when I check my answer, I take whatever I believe it to be, and I plug it into that original equation. Here it is, okay? So that looks like this, putting 25 for x. It says root 25 plus root 25 minus 24 equals 4. And I put a question mark because this is up for debate. You know, like I said, we have to check because there's no guarantee that this answer is actually going to work. So let's see. Root 25 is 5 plus, and then here 25 minus 24 is 1, and the square root of 1 is 1, and equals 4. So is that true? If this was a solution, it would just make this something that we would agree with. That would be true. And it says 5 plus 1 is 4. Is that true? If that's true, then this is a solution. If that's not, then it's not a solution. And of course, like 5 plus 1 equals 4 is completely false. Nobody thinks that 5 plus 1 is 6. It's not equal to 4, so no, okay? So, all right, here's the dilemma that we're in. I solved this, and I got an answer, and I plugged it in, and it didn't work. What's that mean? If there was an answer to this problem, I would have found it here. If the only number that I find doesn't actually work, it means that there's no solution. Okay? All right. If there was an answer, I would have found it through this technique. Checking it would have verified that it worked. That didn't happen. That means the only alternative is no solution. So, okay. This problem and a lot of other problems in math and science turn out to not have solutions, okay? Just because we can write the problem down or think about it or conceive of some problem doesn't mean it's ultimately solvable and that it has an answer, and this is one that doesn't. So we can go back to my math lab, and we got this option, like option A is where if it had an answer, I would put that answer in, but this one doesn't. So I want option B, where it just says the solution is the empty set, which is a very unnecessarily fancy way of saying there isn't a solution. So we'll choose the solution as the empty set, and we'll check it, and it's correct. Okay, now I offer you this the way I offer all my videos that I provide for you. There may be some aspect of this, like maybe you understand 90% of what I've got here, but you get stuck on one particular thing. Like maybe it's like one little aspect of this FOIL multiplication that you're just not getting. When we can have a conversation about that, I can make an additional video. I can help you in some way. Maybe some of this stuff when I rearrange the equation to isolate the root and so on. There may be any little part of this that you get stuck on, that where maybe you understand 90% of what I did, but there's this one little thing that you're not sure about, okay? So always mention that in conjunction with the videos and practicing on my math lab, and then we can take the conversation further from there.